right. Hello. You guys able to comment? Just want to make sure I didn't mess that up. Hello. How you doing, Juliana? So we'll start in like 2 minutes so people get time. Everybody else needs to join. All right. Another minute and then we'll start. All right. All right. So we're going to begin. So what I was going to do first is if you go to yesterday's assignment, it was the Google form called Series and Parallel Math Practice. So I was going to go over both sets of questions in there, and then we can ask any questions that you guys have. And then after that, if you want, we can look at the work for today if you have any questions about the work from today. All right, and if you have any questions, just text it or not. You comment on the side, and then I'll answer your questions if you have any. Okay. All right, so the first one for series practice, we have a circuit, and it looks something like this. All right, we have a 10 ohm battery, 20, 30, and 20 ohm resistor. And the first thing says it just wants to find the total resistance for the circuit. So to find that, we just look at our 3 resistors. And since it's in series, a single path series, we add them together. So 20 plus 20 plus 30 is 70 ohms. So the resistance is 70 ohms. So that's how we get that. Right. And then the next question under that is, using the total resistance you found in the above problem, what is the current that runs through the circuit? So V equals IR, all right, or 10 equals I times 70, divide both sides by 70, and you get 10 over 70, which is 0.14 amps. A couple of you guys had, you just divided the upside down. I got 70 over 10, so I got some 7s or some 0.7s. Just a easy mistake, no big deal. Just Just flip your algebra upside down. All right. Any question about that first problem? Okay. Question, the next one. It's another series problem. So we're going to find the total resistance, 10 plus 20 plus 30. That's going to get you 40, 60 ohms. To find the current, you end up doing 12 over 60, which gets you 0.2 amps. Okay, excellent. And then the last part, what voltage is applied across the 30 ohm resistor? Okay, so for this problem, here's what we need to remember. Since we're in a series circuit, the current that runs through the entire circuit is always the same. Each resistor is going to get the same current. So we just found out for this problem that the current in every resistor is 0.2 amps. Okay, that's what we found before we found R total and then solved for I. So in a series circuit, although the current is the same in every resistor, each resistor has a different voltage applied to it. So to find the voltage, we're just going to use V equals IR. So I'll show you guys in a second. So it's V equals, well, we know the current is 0.2. They all have 0.2 amps running through them. And for the 30 ohm resistor, it's just 0.2 times R, which is 30. And 0.2 times 30 is 6 volts. So that's how we solve for the voltage across one problem. So again, we found out that I was 0.2 amps. All right, that's the current through the whole circuit. If we know the voltage, or if we want to look for the voltage of an individual resistor, we just take that current and multiply by the resistor. So 0.2 times 30 is 6 volts. That's how many volts are across the 30 ohm resistor. Right. That's series work. Does anybody have any questions on series stuff before we get into parallel, which are definitely the more difficult problems? Give you guys a little bit of time. If you have a question, just feel free to write something. If not, I'll go on in a second. All right. Okay. So, new marker. All right, so now let's look at parallel. So if we look at the first parallel problem, so find the total value, or I'm sorry, find the value for 1 over R total and give the decimal answer. So this problem gave a lot of people issues because I made a problem with the Google form itself. So to find 1 over R, so it's 1 over R equals 1 over 10 plus 1 over 2 plus 1 over 1. All right, so that's what it starts out by looking like. Now, if you want to solve for this, you have to find, if you want to add them up as fractions, the least common denominator. It can't be 1 over 13. That's not how we add fractions. If you want to find the least common denominator, it's 10. So we could do it like this. 1 over R equals 1 over 10 plus 5 over 10 plus 10 over 10. And we would get 1 over R equals 1 plus 5 plus 10 is 16 over 10, which is the same thing as 1.6. So that is the value for 1 over R. You can also do this in your calculator, right? And if you type it in like this. Let me see my calculator here. So I'm going to just type in each resistor value, so 10, just like so. And then I'm going to hit this button right above. It's the button that we've been using for the EE button, but I'm not going to actually hit second. It just says X to the negative first. So that actually does the inverse for me. So I'm going to do 10 to the negative first plus 2 to the negative first plus 1 to the negative first, just like that. And as you can see, I get 1.6 as my answer. All right, so that is the value for 1 over R. Okay. What I forgot to ask you, and this is my bad, I forgot to then ask you to find R. So that's the part that gets a little tricky. If 1 over R is 16 over 10, or 1.6, then R is 10 over 16, or 1 over 1.6. Okay, so that's the part that gets a little tricky. So, right, here's 1 over R, 16 over 10, which is 1.6. But then R, we have to flip it upside down. So 16 over 10 becomes 10 over 16. And 1.6 has to be 4. 1.6 gets flipped, and that becomes 1 over 1.6. And if you solve for 1 over 1.6, you get 0.625. That's our total for this problem. And I forgot to ask you guys to solve for that actual number in the problem. So our total, the real value for R, is 0.625 ohms. From there, if we know R, to find the current across the battery, we can just use Ohm's law, V equals IR, all right, or 9 equals I times 0.625. And when we solve for I, we get 9 divided by 0.625, and it's 14.4 amps. And that's how we solve for the current across the battery. We are doing, Christine, the first problem in the parallel part. We just solved for 1 over R, and then we just found the current in that part of the battery, which was 14.4 amps. Okay, so the next question asks, can you find the current that runs through each branch and each resistor, 10 ohms, 1 ohm, and the 2 ohm resistor from the 9-volt battery? Okay, so we have basically something that looks like this. So here is our battery off to the side, and then we have our 3 resistors, 10, 2, and 1 ohm resistor. Well, in a parallel circuit, the current in each resistor is different. However, the voltage applied to each resistor is the same. It's the opposite of a series circuit. So again, in a parallel circuit, the current through each resistor is different. The voltage in each resistor is the same. So if we wanted to find the current in the 10 ohm resistor, we would use V equals IR. The voltage provided, we know, is 9. We're looking for the current, so that's I, and R is 10. So to solve for I, it would be 9 over 10, and 9 over 10 is 0.9. So that would be the current across the 10 ohm resistor. To find the current across the 2 ohm resistor, it would be 9 divided by 2, which is 4.5. And then to find the current across the 1 ohm resistor, it would be 9 divided by 1, which is 9. And that's how we end up solving for the rest of that particular problem. So we first found 1 over R, and then R total. Okay, so again, 1 over R was 1.6. Then R total was 0.625. We were able to find the current across the battery using R total at 9 volts, the given voltage. That was 14.4 amps. And then we are able to find the voltage, the current in each individual branch doing V equals IR, 9 divided by each individual resistor. All right. Does anybody have any questions? Any questions on any of these problems from today? Or from yesterday. And then if not, that's great. If so, no problem. And then we can also look at today's worksheet if anybody has any problems with today's worksheet. If not, then we'll just sign off. Is he gonna come by? Okay. No problem. All right, anybody have any questions at all? Zuri, is that for parallel or for series? All right. Well, here, let's try this out. And let me know, Zuri, if this helps, and everybody else too. Let's say we have this, just a random circuit, parallel circuit, all right, 1 ohm, 2 ohm, and 3 ohms. So the first thing we have to do is determine, is this series or parallel? Gotcha, okay. So we should, first figure out which one's which. So if we look at this problem, if we just trace with our finger, as soon as we determine that there's more than one pathway to get back to the battery, right? Because I can go down, up like this, or I could keep going and go across the 2 and back up, or I can go all the way down to this 3 and go back up. As soon as I have multiple pathways, that's a parallel problem. All right, as opposed to, this is the other one that was series from before. If I trace with this one, all right, there's only one path to take to go from one end of the battery to the other. Single path, S series. So if it's series, we just get to add them together, R1 plus R2 plus R3. When it's in parallel, we have to do the inverse math. So we'll do a practice of this one. Let's try to find out what is 1 over R for this, and then we'll find out R total. So to find out 1 over R, it'd be 1 over R equals 1 over 1 plus 1 over 2 plus 1 over 3. Right, that's the starting point. 1 over each individual resistor, 1 ohm, 2 ohm, and 3 ohm. All right. So we have to find the least common denominator, which would be 6. Okay. So this would become 1 over R equals 6 over 6 plus 3 over 6 plus 2 over 6. And when you add them together, 6 plus 3 is 9 plus 2 is 11 over 6 equals 1 over R. So I now have that right down there in the corner. 1 over R is 11 over 6, right? However, I don't want 1 over R, I want R, so I have to flip it upside down. So if I flip this upside down, I have to flip that upside down as well, all right? And that becomes, all right, if 1 over R is 11 over 6, then R is 6 over 11, and in decimal form, all right, that's 0.545. So again, 1 over R was 11 over 6. So R is 6 over 11. All right, and then 6 over 11 in decimal form is 0.545. All right. Does that help clarify? Besides that question, does anybody have any other questions? Going once, twice. All right. Well, if there are no other questions for today's thing, all right, I'll sign off on this video. Oh, sure. I can definitely do that. So Julianne asked, can we go over 8, 9, and 10 on the work for today? Of course we can. Right. All right. Okay. So what is the current? So 8, 9, and 10 wants to find out what is the current in each individual branch of our parallel problem. All right, so that is what we're being asked for. So let's think about what we know about parallel circuits. Okay? In a parallel circuit, the voltage is always the same across every resistor that's in parallel. All right, so I'm just going to redraw this so we have something to look at together. So give me 1 sec. Three, 2, and 1. Oh, it looks like the one we just did. I just made up. Okay, so here is our battery, and then we have our 3 resistors. First thing we should say, hey, is it parallel or series? We trace, we come up to here. Up, we have more than one pathway. It's not single, therefore it's not series. So we know we're going to have a parallel problem. So again, once it's parallel, we know that voltage is always the same. So V for this problem will always be the voltage provided for you. In this case, it's 24 volts. I just forgot to write it down. So that's 24. All right. And then if we know V is always 24 and we know the values for R are 1, 2, and 3 respectively, we can just solve for I using V equals IR. So V equals IR. All right, so we can rearrange that to get I is V over R, like that. And to solve for each individual current, we would just do this. All right, so for I through resistor 1, it would be 24, right, over 1. For I through resistor 2, it would be 24 over 2. And for I in resistor 3, it's 24 over 3. And then we would get these 3 values for current. 24 amps through resistor 1, 12 amps through resistor 2, and 8 amps through resistor 3. Does that help out, Jules, with the 8, 9, and 10? Did you find your salamander? Okay. Does anybody have any other questions? All right. All right. Anything else from yesterday or from today? All right. If not, guys, have a great weekend. I hope you guys are doing well and staying safe. And I hope we get to see each other again at some point in the near future. All right. Stay safe, everyone, and have a great weekend. Bye.